Welcome back to the deep dive. If you're here, you're looking for that foundational knowledge that really drives elite performance. And today, we are going right to the source. We're plunging into the essential biomechanics of stability, focusing on what every coach, every athlete really has to master. The center of mass, or as we're calling it today, your anchor point.
Yeah, and our deep dive is built on some really distilled knowledge from high-level sports education. So this isn't just academics that you were talking about.
Not at all.
No, it's the universal architecture of, well, a balance and movement. Our mission is pretty simple: give you a rapid and, we hope, a deeply insightful understanding of probably the most fundamental concept in human kinetics.
Okay, so let's start right there. The definition. What exactly is this theoretical anchor point?
So formally defined, the center of mass, or COM, is the single theoretical point where the entire mass of a body is considered to be concentrated. It's a mathematical abstraction, but one with really profound physical consequences.
All right, so for you, the learner, imagine trying to balance a full backpack or maybe a surfboard on one single point, that one spot, that one theoretical spot where the entire object's weight is perfectly supported. That's the COM. It exists inside every object, including us.
And that understanding is it's vital, because sports performance, at its core, is about navigating tension. And that tension is between two extremes, either maximizing stability, bracing for impact in a rugby scrum.
Or defensive stance in basketball, something like that.
Exactly. Or, on the other hand, precisely managing instability to create explosive momentum, like a sprinter driving out of the blocks.
Stability versus instability. It's akin to say it sounds like a contradiction, but in sport, you're constantly flicking a switch between the two.
You are. And everything hinges on controlling that invisible anchor.
Okay, so let's unpack this a bit. If the COM is this crucial anchor point, this single spot defining balance, why isn't it fixed? I mean, if I just stand perfectly still, is my COM always in the exact same place?
That is the first critical insight, and the source material really drives this home. The COM is emphatically not static, not even within your own body. It shifts. It shifts constantly relative to your body structure as the distribution of your mass changes.
So wait, the moment I lift my coffee cup, I've altered my COM.
Precisely. Any shift in the position of a limb, or even just, minor changes in your posture, that alters the distribution of mass. Which means the theoretical balance point also has to move. You lift both arms above your head, and you pull the overall COM slightly upwards and maybe a little forward.
And if I lean over to tie my shoe?
You pull the COM well outside the boundaries of your torso.
Wow. And this shifting nature is what makes analyzing movement so fascinating. Because the best athletes are constantly, and sometimes in really counterintuitive ways, manipulating this point.
You should think about the classic high jump technique, the Fosbury flop.
Okay.
Before that technique, jumpers tried to keep their bodies upright, their COM relatively centered, trying to lift the entire mass over the bar.
Right, like a hurdle.
Yeah.
But the flop completely changed the game. The athlete arches their back, almost like they're lying horizontally over the bar.
Exactly. And by arching their back, letting their legs and head drop on either side, the athlete momentarily moves their entire center of mass outside of their physical body. It can actually go below their torso, sometimes even below the bar itself.
So wait, you're saying their body goes over the bar?
Their hips and torso, yes.
But their theoretical anchor point, their COM, actually passes under it.
Under or right along it. And here's the amazing nugget for you. They get their body over a height barrier while moving their theoretical center of mass a shorter vertical distance. They are literally using biomechanics to cheat gravity.
That's incredible.
It's the ultimate application of managed instability. That ability to precisely control where the COM is going, even when it's traveling outside the physical body. That's what separates elite performance from the ordinary.
Okay, so here's where it gets really strategic. We know the COM is dynamic, it's moving around. But how do athletes actually use that knowledge to maintain balance or, say, resist forces?
Well, the principles they're codified into 4 critical factors that govern stability. We should probably look at the first 2, since they're often used together.
Let's do it.
The first factor is the area of the base of support. So this is the physical area that's encompassed by all the points of contact you have with the ground. The larger that area, the more stable the body.
And that it makes intuitive sense, right? If I stand on one foot, my base of support is tiny.
Yeah, just the sole of your shoe.
Right, and I'm incredibly vulnerable. A small push and I'm over. But if I spread my feet shoulder width apart, my base is so much larger, my stability just skyrockets.
Think about a professional wrestler or maybe a lineman in American football.
Yeah.
Right before impact, what do?
They get wide.
They instinctively widen their stance. They're maximizing that base of support to resist all that incoming kinetic energy.
But they don't just widen their base, do they? They also drop down. And that leads directly into the second critical factor, the height of the center of mass.
Correct. Lowering your comm increases your stability. So if you take that same wide base of support, but then you crouch down, you become significantly harder to push over than if you were standing tall.
That classic wide, low stance, the defensive basketball player, the sumo wrestler. It's the perfect mechanical combination.
It is. They're bending their knees and hips, actively bringing that theoretical comm point closer to the ground, while at the same time maximizing their base.
So they're effectively increasing the distance that an external force would have to push them to get their line of gravity outside their support base.
And we'll get to the line of gravity in a moment. But yes, think of those huge concrete barriers they use on highways. They are low and wide for a reason.
They're designed to be maximally stable, impossible to move.
Exactly. So if you're an athlete and your primary job is resistance, a goalkeeper preparing for a shot, a martial artist holding a position, you are strategically aiming for a low comm and a wide base of support. It's basically biomechanical armor.
Okay, so we've got the base of support and the height of the comm. What about the third factor? This one seems less immediately controllable, but still massively important.
The third factor is simply the mass of the body. Generally, increased mass leads to increased stability and inertia.
So this gives a clear mechanical advantage to bigger athletes in situations that demand stability.
Right. A heavyweight boxer is just inherently more stable than a flyweight, assuming all other factors are equal.
Why is that, mechanically?
It's because greater mass means greater inertia. And inertia is just the body's resistance to a change in its state of motion. So if you have two athletes, identical postures, identical bases of support, the one with more mass is going to require exponentially more force to destabilize or move.
And we see this influencing the entire structure of sports, right? Weight classes, position-specific body types. A sprinter is focused on acceleration, so they're managing instability. A shot putter, though, is resisting immense forces, so they use their mass for stability.
It's a fundamental trade-off. An athlete has to make a strategic choice. Do I bulk up for maximum stability or stay lean to maximize speed and agility?
Okay, now let's connect all three of those factors to the fourth, and you said most critical element, the actual position of the comm relative to that base of support. This is where balance is won or lost.
This is where we have to introduce the line of gravity. This is the key to understanding the limit of stability.
Tell us more about this line of gravity. How can we visualize it?
The line of gravity is, well, it's an imaginary vertical line. And it passes directly through your center of mass. So if your comm is somewhere near your navel, the line of gravity is like a plumb line, dropping straight down that point to the floor.
So if I'm standing balanced, that invisible plumb line lands smack in the middle of my base of support between my feet.
Exactly. The source material is clear that stability is maintained only as long as that line of gravity falls within the physical boundaries of your base. Your feet, your hands, whatever is touching the ground.
So that concept, it defines the boundaries of your control. It's like an invisible safety zone.
It absolutely is. Think about when you lean forward to push something heavy, like a box. You intentionally shift your comm forward, right? You're moving your line of gravity closer to your toes. You're using that shift to transfer momentum into the box.
But there's a limit. There's a point where you lean too far.
That limit is the precise moment that the vertical line of gravity crosses the forward boundary of your base of support, the very edge of your toes. The moment that line crosses over, you've hit the point of no return.
And if that line of gravity falls outside the base, your body just... It can't generate enough muscular force to pull the comm back. So what happens?
You fall. Or, more likely in sports, you're forced to take a step. Taking a step is the body's emergency response. It rapidly creates a new base of support underneath that now off-center line of gravity, and it restores your stability.
So elite balance is really about an athlete constantly pushing their line of gravity right to the very edge of their base, but without letting it cross over.
Yes, think of a baseball pitcher. During that wind-up and delivery, their comm and line of gravity are shifted dramatically forward over their plant foot. They're loading all their weight, creating maximum instability in that forward direction so they can unleash all that momentum toward the plate.
But they have to stop just short of that point of no return. If they overshoot, they fall off the mound or the pitch goes wild.
Every single explosive movement in sport, a sudden cut in football, A pivot in tennis, a launch in gymnastics, it's a strategic dance with the limits of stability. The athlete generates maximum force by pushing their calm as far toward the edge of their base as possible, harnessing that near-fall energy, but always maintaining just enough control to recover or execute the skill.
This has been a really fascinating breakdown of what seems like a simple concept, but is so clearly the dynamic foundation of all physical performance. Let's just bring these core knowledge nuggets together for a final time.
Okay. We began by defining the center of mass as that theoretical anchor point. And we noted its dynamic nature, how it shifts with every movement, and can even exit the physical body.
Right. And then we broke down the 4 critical levers that athletes use to control whether they are stable or unstable. The size of the base of support, the height of the column, the overall mass of the body, and most crucially, the precise relationship of the line of gravity to that base.
So what does this all mean for you, listening? It means that when you watch high-level sport, you're not just seeing athleticism anymore. You're seeing applied physics. You are seeing athletes strategically choose to maximize stability in one moment
Like a defensive block.
and then instantly pivot to maximizing instability, pushing that line of gravity right to the boundary to create acceleration in the very next moment.
That seemingly simple act of standing balanced or running fast, it's actually a continuous split-second calculation of where that invisible vertical line lands. And the mastery of this anchor point is, it's literally the difference between controlled momentum and a catastrophic loss of control.
Understanding your anchor point is key to elite performance. For the full Stability Lab, visit revisedirect.com.
That is all the time we have for this deep dive into the mechanics of movement and balance. We really hope this has given you a whole new lens to view physical performance. We'll catch you next time.